Our first lesson is lesson 6, Speed STEM in Action in Theme2. STEM in Action always helps us apply what we learn in our daily life situations. We will apply what we learn about motion, speed, energy by exploring solar-powered cars. Mechanical engineers design cars and think about how to use energy to power these cars in creative ways. Gasoline vehicles. Most cars are powered and operated by gasoline as a fuel, but these cars produce exhausts that pollute the air and cause climate change. As we learned before in Theme 1, the air pollution is because the exhaust produced from cars and from factories. So mechanical engineers think about how to reduce pollution and to use a clean form of energy, an unharmful form of energy. That's why they think about using electric vehicles. The electric vehicles, they are powered by electricity, but these electric vehicles have batteries that must be charged from time to time. As our mobile phones, we have to charge them from time to time. Also, they think about solar vehicles. They design vehicles that are powered by the sun, solar energy. But there are some difficulties in solar vehicles because the amount of energy we can get from the sun is not as great as the amount of energy we get from gasoline or an electric battery. So engineers reduce the weight of the solar vehicles to make them drive as quickly as normal vehicles. Let's study the pros and cons of the solar vehicles, or the advantages or disadvantages of using solar vehicles. The advantages is that they don't need gasoline to move. Also, they don't need to charge their batteries using electricity. And of course, they don't cause air pollution or climate change. But also the cons that they are slow. They are slower than the cars, the gasoline cars and the electric cars, because the amount of energy that we can get from the sun is not as great as the amount of energy that we can get from gasoline or electric batteries. That's why mechanical engineers think how to make it faster. So they try to reduce its weight by removing the speedometer, but also that make it difficult to measure the speed. But you can help mechanical engineer to measure the speed as we learned before. So we can measure the speed by measure the distance of the solar vehicle that travel over the time taken by the car to travel that distance. So by measuring the distance and calculate the time, we can know the speed. Concept 4. Energy and collisions. We are going to learn in this concept how the speed affects the severity of collision. And also we are going to learn the factors that affect car crashes severity. So first we have to know the meaning of collision. Collision is when two objects hit each other in a forceful way. And during collision, there is a transferring and transforming of energy. When an object, as a truck, hits another object, as a car, we observe that energy is transferred when objects hit or collide with each other. A faster and heavier object, it means it has more mass and more speed, has more energy than a slower and lighter object. Therefore, the faster and heavier object has more energy, causes more damage than the slower and lighter object that has less energy. And we are going to study two examples for collision. The first example is the wrecking ball. The wrecking ball is a very heavy steel ball that swings on a cable. The wrecking ball is used to collide with walls of a building, help construction workers knock down walls or parts of buildings. As you can see in the wrecking ball example, by pulling it up to a great height and by releasing the ball, it transfers the potential into kinetic energy. As you can notice, by pulling it up to a high or a great height, its potential energy increases, and by increasing its potential energy, we increase the kinetic energy when we release the ball, moving towards the wall and crashing into it. The collision in cricket. The second example. Cricket is a popular game all over the world. In cricket, a player uses a wooden bat to hit a ball. The cricket player holds a bat and moves it as the ball comes towards him at high speed to collide with the bat. In this example, it's different from the other example of the wrecking ball because here the two objects are moving. The bat is moving and the ball is moving. The player is holding the bat and moving and pull the bat towards him and moving forward, so this is kinetic energy. Also the ball is moving towards the bat, so also the ball is moving and has kinetic energy. This is different from the wrecking ball because the ball was stable, it wasn't moving. So here the collision change the direction of the ball and increase its speed by transferring the kinetic energy from the bat to the ball. The bat transfers its kinetic energy to the ball, then the speed of the ball increases and the ball returns back in a different direction. Also the ball transforms some of its kinetic energy to the bat in the form of sound, as we can hear the sound of popping when the ball collides with the bat. And also the friction force happens during the collision, makes another transform of energy into heat energy. So as you can see here, the bat is moving and the ball is moving, and when they collide with each other, there is a transform of kinetic energy into a popping sound and heat, and also there is a transform from the kinetic energy of the bat to the ball and from the ball to the bat. As you can see also, the ball is moving in different direction and it increasing its speed. And we have several examples for collision in our daily life. For example, in a tennis serve, the transfer of kinetic energy from the tennis racket to the ball, where it increases its speed and change its direction. And also there is a transform of energy into sound energy, where we can hear the sound of popping of the ball, and heat energy produced because of the friction force happen between the ball and the tennis racket. Also in a bowling game, where we can see that it is affected by the speed, force and mass of the bowling ball. So the collision of uh, the bowling bats depend on the force and the speed and the mass of the bowling ball. And the last example here in the golf swing. As we can see, the kinetic energy of the golf bat transfer into the golf ball, and that move it forward, and there's some transformation of energy into sound energy and heat energy due to the friction force happening between the bat and the ball. Now think, how can we use energy, motion and speed to improve the safety features of the passengers in vehicles during collision? While watching object collides, of course you noticed before that after the car stops suddenly, your body continues to move forward. And when the car collides with a high speed, and if the car is speeding up, you might hit the glass. That's why scientists think about safety equipment to keep the driver and the passengers in their places. Like, first example, the seat belts. The seat belts are used in cars to keep the driver and also the passengers from moving forward when the car stops suddenly. So seat belts have saved thousands of lives. So as you can see here, the seat belts keep the passenger and keep him from moving forward. The second feature here is the airbags. Airbags are made up of thin nylon material folded into the steering wheel, seats, dashboard or doors. Idea of operating during a crash airbag. The airbags inflate automatically when sensors in the car detect a crash. A sensor tells the airbags to inflate and fill with gas to provide a soft cushion. After a collision, the airbags deflate almost as fast as they inflate because they have holes or vents to allow them to deflate, so the driver can get out of the car. As you can see here in the example, when the sensor detects the crash, the airbags inflate automatically, and it absorbs the energy from the passenger or the driver when moving forward. So the airbag slows the speed of the driver moving forward airbags and absorbs the energy of the car during its collision. We just saw how cars collide and how the passengers are affected by the collision. But can you imagine a car collide with a train? There are many accidents in which a train hits a car that may be stuck on the train tracks. Trains are much larger than cars. Also, trains travel at higher speed than cars, so it's more dangerous as the force of the collision between the cars and trains increases. Here the train has a very big mass and the car has a small mass. Also, the train has a very high speed, while the car has a slow speed or no speed because it's stable, it doesn't move. So as you can see how dangerous is the collision between train and cars. That's why scientists think about how to improve the safety during collision between trains and cars. So they think about putting a huge airbags in the front of trains that can inflate automatically and reduce the impact of collision to absorb the energy from the train and the car. So let's summarize our lesson. We learned how mechanical engineers used energy, motion and speed to save energy as much as possible and use a clean form of energy that doesn't harm our environment. Also, we studied pros and cons of using solar vehicles, or advantages and disadvantages of using solar vehicles. Also, we learned how to calculate the speed of a solar vehicle as they remove the speedometer from the solar vehicles to be lightweight. That's why we use the formula of speed to calculate the speed of a solar vehicle. And also we wondered about what happened to objects during collisions. And we started to explore the cause and the effect of collision and energy transfer. And we learned about collision between two moving objects, as in the cricket bat and the ball, and a collision between a moving object with a stable object, as in the wrecking ball. And we studied how the speed and mass can affect the collision and the amount of energy it has, and how we use these facts and information to invent safety features that protect drivers and passengers during a collision, as seat belts and airbags. So what happened to the objects before and after collision? That's what are we going to explain in the next lesson, in the next video. Thank you for listening. Bye.